Welcome. So what I have here is f of x equals x cubed minus x squared minus 6x. And what we're going to do in this equation is we're going to determine our end behavior, our zeros, and multiplicity. So let's do the end behavior first. What we notice is we have a degree that is odd, and we have a leading coefficient that is even. So therefore, our end behavior is going to fall left and rise right. Now, to determine what the zeros are, we need to take our output value for this function, which is f of x, and set it equal to 0. Now we need to find the values of x that are going to make this true. And you can see we have a lot of x's on this right side, right? Well, I can't solve for individually one of them, so what I'm going to have to do is factoring. And the first part about factoring we always want to look into is factoring what they have in common, which we call the GCF. So we see that they all have an x in common, so when I factor on x, I'm left with x squared minus x minus 6. Now again, we always want to be able to determine, can I factor that down even further, right? Because if I was to apply zero product property, I would have this set equal to 0, and I still need to find the value of x. So I need to now factor x squared minus 6x minus 6. And to do one of those, again, we can remember at what two values multiply to give us negative 6, but then add to give us negative 1. Well, I could factor that to negative 3 and positive 2. Therefore, I could rewrite this now as 0 equals x times x minus 3 times x plus 2. So now I have the product of each one of these factors multiplying to give me 0. I can apply now the zero product property to solve for my zeros. OK, so therefore, I already know x equals 0. Here I'll add 3 on both sides. X equals 3. Here I subtract 2 on both sides. X equals negative 2. And now I have all three zeros. So to determine the multiplicity, I need to go back and look at the factors. I can write x as x minus 0 if I wanted to put it in parentheses. But we notice that the exponent of each one of our factors is going to be 1. So therefore, each one of these zeros have a multiplicity of 1, which is odd. So therefore, we know that at each one of these zeros, our graph is going to cross at the 0. There you go, ladies and gentlemen. That's how you solve the problem. Thanks.